Nova number 617, The Bridge That Spanned the World, a BBC WGBH co-production.
Major funding for Nova is provided by this station and by other public television stations. Additional funding is provided by grants from TRW and the National Science Foundation.
We are celebrating the 200th anniversary of the world's first cast iron bridge. As an American, I've come to this English valley in a year of celebration to share experiences present and past. This valley is full of strong memories of the Industrial Revolution, some pleasant, some disturbing. There are also industrial monuments, like this bridge, recalling the determination of the people to survive, even thrive, in an unnatural world becoming industrial.
200 years ago, the world's first iron bridge was erected, a symbol of the future possibilities of industrial technology. Fittingly, it spanned the Severn River, at that time the center of the burgeoning Industrial Revolution. Discoveries made in this valley at Ironbridge and in nearby Coalbrookdale in the 1700s gave birth to today's use of iron, all the way from high-rise buildings to automobiles and refrigerators. The iron bridge was built to span a gorge formed by the river cutting through accumulated deposits of iron, coal, and limestone. The smaller valley of Coalbrookdale runs off to the north. The area lies in the west of England, near Birmingham. Here, in Shropshire, was a remarkable family of ironmasters, the Darbys. In the early 1700s, they helped kindle the Industrial Revolution. They put together a pattern of iron-making, transport, and invention so logical that it was to transform the world. Beneath today's covering of trees, the remains of their system still exists. The inclined plane is a railroad up a hill which lifted boats from the river to a canal 300 feet above. Today, this foundry is at the site where the metal for the first iron bridge was cast. And the Darby's Bridge itself links the banks of the Severn, the longest river in England.
The Quaker Darbys were the leading family in this valley from 1700 until 1850. There were no less than 4 Abraham Darbys who were iron masters. The Darby family has been called a dynasty of iron founders. But the word dynasty will not do if it implies force and rule. For the Darbys were Quakers, they were pacifists, and they believed in the equality of women and men. For 150 years, they made good iron and strong marriages. Daughters married iron masters, and granddaughters married rich Quaker merchants. The family tree was a wonderfully complex one. The man who saw first the possibilities of the valley was Abraham Darby the first.
The first Darby started business downstream at the port of Bristol, a city which was a stronghold of Darby's brethren, the Society of Friends, the Quakers. The Quakers had survived as a persecuted minority, attacked for their pacifism and unorthodox dress. They were prevented from holding any public office and were denied entrance to the universities. But they built their own academies to provide a practical, even vocational education fitting for careers in industry and trade. Darby was successfully manufacturing cooking pots made of brass. Then he wanted to try a new process to make cheaper, stronger pots with iron. But his attempts at cast iron technology failed. Only when an apprentice, John Thomas, asked Darby to let him try was there a breakthrough. John Thomas's innovations succeeded. Iron pots were cast. Cheap and strong, they were an immediate success. For generations, they went from Bristol docks all over the world. Even today, they are perhaps the most recognizable objects the Darbys made. They were sent as cooking pots to Africa and the South Seas. Whaling vessels carried them to render down blubber. And they were taken up by traveling people for concocting brews and potions. In 1708, Darby moved his iron pot business from Bristol up the River Severn to the iron deposits of Coalbrookdale. This out-of-the-way area, where even today a prehistoric fishing boat, the coracle, can be seen on the water, had long had a small-scale iron industry. The river was crucial to Darby's plans. Roads at the time were almost useless for moving heavy loads, and there were no canals or railroads. The River Severn would be the highway linking Darby at the manufacturing site with his Quaker merchant friends at the port of Bristol. Darby acquired one of the already existing blast furnaces. Into this furnace went local materials: ironstone, limestone, a flux to draw the impurities out of the iron, and the fuel, charcoal. Bellows pumped in great blasts of air to keep the burning mixture at red heat as the ironstone was reduced to iron. Molten metal was tapped off at the bottom into a trough with side gullies which looked rather like a group of piglets feeding from a sow, so the final ingots were called pig iron. Now Darby had a revolutionary idea to use a new fuel, coke from the local coal deposits rather than the charcoal, to make a hotter, more fluid iron, better for casting pots. He directed experiments from the nearby manor house at Madley Court.
Abraham Darby came to the Dale to make pots. In fact, he made history. Like most able inventors, he defined the problem precisely. He needed an iron that would flow easily into the complex mold of his pot. He reasoned by analogy to a likely solution. Why not use iron made with coke instead of charcoal? In Bristol, he had seen coke used to dry malt. He had used it himself to melt metal. He learned by experience that coke makes a hotter fire than charcoal, and the metal made in the fire flows more freely. He came to the Dale to experiment. Within a year or two of arriving, he had success.
Darby was producing coke iron very suitable for pots, but as yet it was too brittle for other applications. But he experimented with furnace technology, dimensions, loadings, and air blasts to develop coke iron suitable for other uses. So when, in the middle 1700s, timber shortages forced the price of charcoal to rise steeply, other iron masters turned to Darby's coking methods. And Darby's pioneering efforts started to affect history. Coke-fired iron production caught on, and output expanded. The modern Iron Age had begun in the valley of the River Severn in England. Meanwhile, one of Darby's relatives had sailed to America, named his settlement Coalbrookdale, and set up the first blast furnace in Pennsylvania. There's little sign that there was ever an iron works here on Ironstone Creek in the American Coalbrookdale township, but this is where iron making began. The story of the two Coalbrookdales, an ocean apart, now runs in parallel, but with a definite time lapse. The Americans carried on making their iron with charcoal for more than 100 years after Darby's changeover to coke in England. America had so many trees that charcoal remained simply the cheapest fuel available. Not far from American Coalbrookdale, at Hopewell Furnace Village, Pennsylvania, ironmaster Mark Bird used charcoal to make cannon for George Washington in the Revolutionary War. But America, as yet, was sparsely populated, and native iron production remained small-scale. But despite the small scale of production, men like these charcoal burners polluted the skies of America in the 18th century and depleted her forests. They had to use almost an acre of trees to make one of these piles to turn wood into charcoal by controlled burning. The bluish smoke from such piles was a familiar sight in the woodlands of 18th century America.
The work was dirty, and when the charcoal burners came in from the pile after the burning, mothers sometimes frightened the children by saying the charcoal burners will get you. Now, the iron master down at the furnace, he depended upon these people. One of his major problems was obtaining enough charcoal to feed the furnace each day.
Sometimes, despite the abundance of wood, the charcoal burners couldn't keep up with the demand. To make charcoal, the charcoal burners took wood, which had been brought in from the forest, and stacked it very carefully into a pile that could reach almost 20 feet in height. The pile would then be lit by dropping burning charcoal down the carefully constructed central chimney. The pile would then be smoldered for 2 weeks, and the charcoal burner who lived in a hut nearby had to watch out for flames. If flames broke out, it meant the pile was getting too much oxygen, that air was coming in through a coating of leaves that had been placed on top of the pile to keep out excess air. What was needed was a slow, smoldering burn that would drive off the volatile substances which, if left in the charcoal, would have poisoned the iron.
After the long process and the heavy work, there was only enough charcoal here to keep the furnace running in blast for perhaps a day or two. And the furnace consumed a prodigious amount of trees. It took 300 acres of land, trees growing for 25 years to supply this one furnace. And this furnace only produced 2 tons of iron a day. This furnace flourished when America had an abundance of water and an abundance of wood. The wheel mechanism here is being used to provide the air for the furnace. America had an abundance, and she used it well into the 19th century, when shortages began to develop. The case was different in England. In 18th century England, there was a timber famine, and the best water power sites had already been exploited.
And so it was back in England in the 1750s that the ingenuity and inventiveness of the Darby family reaped its reward. Their coking methods removed the limits to the growth of iron production. They leapt forward into the Industrial Revolution, making cylinders for the first stationary steam engines, casting the first iron railway wheels, making iron rails when the wheels turned out to be too robust to run on wooden trackways. Eventually, the Darbys were to build early experimental steam locomotives. But with increasing production, water supplies became a problem. The furnaces had to close in summer when the rivers ran too low to drive the water wheels. They overcame this obstacle by using a stationary steam engine to recycle water from the lower end of the dale back to the top, where it was stored for reuse. To keep business booming, the raw materials for iron making had to be obtained as cheaply as possible. The local limestone was used as the purifying flux in the furnaces, and to run the lime quarries on nearby Lincoln Hill, they used a naturally free source of energy.
The end of the tunnel is blocked by a rockfall, and the entrance is almost covered with brush. But in the 18th century, the tunnel was a scene of intense activity. It led into the center of Lincoln Hill. Lincoln Hill was called a monstrous limestone rock. It had been hollowed out by a deep quarry. At the bottom of the quarry, there were large caves, man-made caves, probing into the limestone. The limestone came in cars, along rails, down and around this earthen platform. At the very edge, the cars were tilted, and the limestone discharged down a chute into the top of the kiln, where the limestone was converted into lime. There was an alternative route. The cars could be run along rails into another tunnel, which extended thousands of yards to Bedlam Furnace, where the limestone was used as a flux. Because the raw materials were high in the hills, and the chief mode of transportation, the river, was low in the valley, the force of gravity could be used. The 18th century was cleverly using an inexhaustible source of energy.
By now, Abraham Darby II had taken over. He perfected his father's coking method and could now turn out quality iron for all types of work. He borrowed heavily to expand the business, as his wife comments in a letter dated 1757.
My husband hath begun to build 2 furnaces at Ketley. He hath laid a new railway to it. So now the railway is got down to the Dale to Severn. It is 5 miles in length. My husband delights in laying out money, and when he'll stop, I don't know.
He stopped in 1763, leaving behind a pile of debts and a son 11 years old. His father had died young, too. But the family survived and the company prospered with the aid of a family barely mentioned in the history books. The family that provided the support and the advice was named Goldie. It lived here in this house. Rich merchants and traders often buy or build handsome houses and indulge themselves in eccentricities such as this grotto. The Goldneys were Quakers, but no exception. But they also invested their money in other enterprises. In 1708, Thomas Goldney helped outfit 2 privateers, the Duke and the Duchess. These brought handsome returns to him through booty and prizes, a very un-Quakerly enterprise. But there were investments from the Goldneys in industrial enterprises as well. Thomas Goldney helped Abraham Darby establish the Coalbrookdale Works in 1708, and the Goldneys continued to supply money. They made it possible for the Darbys to improve the ironworks by improving upon the furnaces, building canals, constructing reservoirs, and making other technical changes. The Goldneys kept a close watch on their investments. They influenced the appointments of managers. They took part in the sales of the merchandise.
The Goldneys supplied venture capital. They helped transfer funds from the merchants of Bristol upstream to the manufacturers in Coalbrookdale. They were the investment bankers of the 18th century.
Large corporations today use intricate diagrams to show the relationships between the branches of the company, personnel, and position. There were also networks in the 18th century, Quaker networks. These resembled family trees more than the impersonal geometrical diagram. The bonds of the Quaker network were the ties of kinship, fathers and sons-in-laws, brothers and sisters, and cousins. Where blood failed to tie, then the deep trust and friendship of the Quakers served. Along these 18th century networks flowed the capital of the Goldneys and the technical know-how of the Darbys. The Darbys, the Goldneys, and the Reynolds, they were bound by the ties of blood and the ties of iron.
Richard Reynolds was a Goldney nominee who ran the company while Abraham III was growing up. A shrewd businessman, he was also an ideal Quaker, as a family memoir recalls.
He would follow a poor person to his or her house to apologize if he had spoken warmly in the heat of temper. It was painful for him to see waste. Respecting the long dresses of the time, he remarked, I cannot bear to see sweeping on the ground that which would clothe a poor shivering child.
Agricultural workers, hoping for a better life, came to work in the Dale. They formed a restless and sometimes violent society, even though the company built rows of workmen's cottages all over the area.
This is a house for Derby work people. It's on the hill just above the furnace and the foundry. The Derbys provided better living and working conditions for their people than was average in the valley. This was because of the Quaker conscience, and also because the Derbys needed more skilled workers, and the workers could demand more. The house appears cozy, but we should not be deceived. As many as 7 people and 3 generations might have lived here. And there was a dismal view out of the window down to the industrial landscape. But life in the 18th century was not centered upon the home. The skilled workers undoubtedly took pride in their work, and the unskilled workers had ways of protecting themselves. That was drinking and roistering about. The church provided warmth, and there were Sunday schools, and Richard Reynolds had built scenic walks for Sunday afternoons.
When Abraham Darby III took over this benevolent dictatorship in the 1770s, he looked at the industrial empire his family had created on both sides of the Severn. He saw that the river, which was its lifeline, also split it in 2. People and materials could only get from one side to the other by boat. What was needed was a bridge. And as a Darby relative recorded in 1777, it was to be a revolutionary bridge.
The bridge is now fixed upon to be an iron one, which certainly, when completed, will be one of the great curiosities that this nation or any other can boast of. I suppose it will all be cast in the Dale, for Cousin Abraham will have the whole direction.
The design was a tremendous leap into the unknown. This was no small-scale experiment, no pilot project. Abraham I's old furnace still stood in the Dale. His grandson had to enlarge it substantially in 1777 to produce the 370 tons of iron required. The arch carried on massive stone abutments was to span 100 feet. The amount of labor involved becomes clearer as one part of the bridge, the centerpiece of the parapet, is specially recast for this program by today's Colebrookdale Company. Its foundry still stands on the site where the original bridge was made. The first stage is to make the pattern, a full-size wooden version of the piece to be cast, exact in every detail. This skilled and laborious technique has always been the foundation of making castings in iron. Only the price of the job has changed. In 18th century England, the entire bridge was built for less than £3,000. Today, just the decorative centerpiece by itself costs 1/5 of that entire amount. When the different parts of the pattern are assembled and painted, they will be pressed firmly into the molding sand. The sand is damp, which allows it to hold the impression without crumbling, like Man Friday's footprints on the beach. The result is negative, the pattern reproduced in reverse. The downgates through which the molten metal will be poured are put into place. The open floor molding method, rarely used today, has changed little in 200 years. A chronicle recorded the method.
On a wide surrounding space are numerous molds in sand. Into these the fluid iron is poured from ladles with long handles, carried by athletic workmen who fill these utensils from the circular reservoir. Were it not that the laborers are supplied with gloves, so constructed as to protect them from the violence of the heat, it would be impossible for them to perform their work.
The crucial moment approaches, the pouring of the iron. To ensure perfection, the craftsmen at each end must act in complete unison. Three hours later, the casting is solid enough to be broken free of the mold. This centerpiece weighs over 300 pounds. Moving the centerpiece is easy enough, but in 1778, moving the ribs of the bridge, its main support, must have been a difficult job. Each of them is 50 feet long and weighs nearly 6 tons. Darby was an inventor and entrepreneur, but not an imprudent one. The bridge is an old-fashioned wooden one made in iron. Darby cut his risks by relying on tried and trusted methods. Some of the members are slotted through others, just like a timber bridge. The joints are held in position by wedges. The main ribs themselves are over-engineered, far too large and heavy for the work they're required to do. The builder's justification is that they have survived 200 years. The only threat to the bridge has come from movement of the riverbanks, not weakness in the structure itself.
The bridge spans more than the Severn River. It spans 200 years. Of course, it is an economic and it is an engineering triumph. After the bridge was built, ore, coal, people, goods could move across far more easily than when the ferry boats were used earlier. And after this bridge was built, other architects and other engineers built bridges lighter and a broader span. But it's the form of the bridge that is a striking image. The bridge is industry become art. When the grime and when the smoke clears from the valley, we see this handsome bridge standing as an expression of our shared aspiration that the world we make, the industrial world, will be both useful and beautiful.
Writers and travelers were irresistibly drawn to the area, for the iron bridge symbolized progress and the synthesis of coal, iron, and transportation, which was the essence of the Industrial Revolution. 18th century travelers voiced their impressions.
Coalbrookdale itself is a very romantic spot. Indeed, too beautiful to be much in unison with that variety of horrors art has spread at the bottom.
But of the iron bridge, what shall I say? That it must be the admiration, as it is one of the wonders of the world.
The approach to Coalbrookdale appeared to be a veritable descent into the infernal regions. A dense column of smoke rose from the earth. Volumes of steam were ejected from fire engines, and smoke arose from a mountain of burning coals which burst out into turbid flames.
Really, if an atheist who had never heard of Coalbrookdale could be transported there in a dream and left to awake at the mouth of one of those furnaces, though he had been all his life the most profligate unbeliever that added blasphemy to incredulity, he would infallibly tremble at the last judgment that in imagination would appear to him.
Almost immediately, a town began to grow at the north end of the bridge. Visitors stayed in the hotel the Darbys helped to build below the church. It was an iron town. Iron chimneys, iron windowsills, iron railings, iron everywhere. Ironmaster William Reynolds, the son of Richard, was the valley's next leading figure.
William Reynolds was of the Darby line, a grandson of Abraham Darby II and a cousin of Abraham Darby III. He was a man of engineering sense, of scientific reason, the last inventive genius of the line. Like other engineers of his time, he used gravity resourcefully. The logical and systematic William Reynolds asked why waste money, time, and energy lifting coal from the bowels of the earth to the top of the pit shafts and then down the side of the hill to the river level and the furnaces. Why not drive a tunnel at river level into the hill, then roll the coal out on rails or float it out on boats? He was a lucky genius. The men driving the tunnel struck springs of a tarry substance. The tar collected in pools like this one, the men brought it out of the tunnel. The company sold it for treating hemp and caulking boats. It was also distilled, bottled as Benton's British oil, claimed to be a cure for rheumatism. The tunnel served as part of a transportation system, but canals were needed as well.
Transport was the key to industrial expansion, and Reynolds built the Shropshire Canal with great difficulty on the fissured and undermined ledge of hills overlooking the gorge. A series of inclined planes, railroad tracks up the hill, was his solution to the problem of moving goods speedily from one level to another without wasting time through flights of locks. This was the first industrial application of the concept. This incline ceased working in the 1890s. It's been excavated and carefully restored, and now a special reconstruction shows it working again for the first time since the 19th century. Barges coming from the Severn approached along a short section of canal running from the waterfront. The barges, called tub boats, were hauled to the bottom of the incline, where a trolley picked them up from underneath. Each trolley could handle a load of 5 tons and carry it to the canal above in 3 minutes, 20 seconds. Ascending loads were lifted by steam-driven winding gear. But the rising trolley was more often empty. Then its weight was counterbalanced by a full boat coming down on the second track, and gravity did most of the work.
I've just been on the inclined plane, a splendid invention and a nice ride. The iron masters and their skilled workmen were problem solvers, engineering problem solvers, and their solutions were often new developments and sometimes notable inventions like the inclined plane.
The men who built these machines had an overriding concern to devise practical solutions to the obstacles in the way of expanding iron production. They needed a smooth flow of materials and energy between their mines, their furnaces, and their foundries. Any interruption in this flow was a serious problem and required a solution, like the inclined plane.
The ultimate solution was raw material flowing into the furnaces, water streaming over the great wheels, and air smoothly flowing through the blast bellows, with the products moving up and down the transportation routes of England.
Reynolds was a man of many ideas besides the plane and the canal. He founded a new town of Coalport downstream of Ironbridge to make pottery and to be a river harbor. He experimented with steel making and distilling tar products to make chemicals. He was constantly moving to the frontiers of new technology. At the top of the incline, boats floated off their trolleys, ready to move to the works along the canal banks, in many of which Reynolds had interests. Although there were danger signs, supplies of iron were beginning to run low, it was a time of promise. But in 1803, like many of the Darbys, William Reynolds died in his prime, and most of his projects died with him. Depression followed the wars against Napoleon, which ended with the Battle of Waterloo in 1815. In 1818, the Darbys' original furnaces in Coalbrookdale were shut down. Shortages of raw materials were making the valley physically old and rather tired. Heavy iron making had moved to Wales and Scotland. The company revived its fortunes by moving into the field of decorative ironware. More prosaically, the firm also ran a line in solid fuel stoves, a product it still turns out today. At the time of the Great London Exhibition of 1851, the company still had 3,000 workers, but its days of glory were over. The baton of industrial invention and entrepreneurship had passed across the Atlantic to American hands in the Lehigh Valley of Pennsylvania.
History does not repeat itself in detail, but there are remarkable similarities between the Severn Valley in the 18th century and the Lehigh Valley in the 19th century. Both valleys are called birthplace of the Industrial Revolution. The one, the birthplace of the British Industrial Revolution, the other, the birthplace of the American Industrial Revolution. Both valleys were the world center of iron production, one in the second half of the 18th century, the other in the late 19th century.
The key to the American takeover lay in the huge deposits of anthracite coal which lay around the riverbend location of Mauch Chunk in eastern Pennsylvania. Here in the early 1880s, Josiah White had seen the possibilities for industrial development. The area had raw materials, energy, and river transportation to the sea, the same elements that Abraham Darby I had perceived in the Severn Valley 100 years earlier. Josiah White became the entrepreneur of the American Industrial Revolution.
Josiah White was a broad-visioned Philadelphian, and he was a Quaker, like the Darbys. In 1818, he leased anthracite coal beds in this Lehigh Valley region. He saw that the problem was to provide a transportation system for the anthracite coal, a way of reducing the price of the coal so it could be used in different industrial enterprises in Philadelphia, in New York, and various places on the eastern seaboard. He came here after 1818, and first he improved the navigation of the river, the Lehigh River, and then he built a canal, one of America's outstanding canals, the Lehigh Valley Canal, an abandoned lock of which you see here. This was the Way Lock.
Not only did White build one of the most heavily used canals of the time, but he also built America's second railroad line. It was a gravity-feed railroad, like Darby's inclined plane, and it extended 8 miles from the hills down to the river and to the canal where the anthracite coal was loaded. White's Canal Company flooded the Philadelphian market with cheap anthracite for burning in home stoves. By 1840, the price of anthracite had fallen to a level which it passed again only well into the 20th century.
Josiah White was a revolutionary, an industrial revolutionary. He transformed a wilderness into a building site, a very American thing to do. He was an inventor. He boasted of his patents, but he was more than an inventor. He was more than an engineer, although they called him in to complete the Delaware Canal when others were unable to do it. He was also more than a manager, but he directed one of the largest corporations in early 19th century America. A 19th century man, he was a precursor of Henry Ford and John D. Rockefeller. He designed, he organized, he coordinated with a singleness of purpose He created a system that mined, smelted, transported, and marketed. Because of Josiah White, coal flowed from the Lehigh Valley.
The infant settlement of Mauch Chunk suddenly became a real place on the map, a town which eventually contained more millionaires to the acre than anywhere else in America. For White had had yet another idea. He wanted to increase his anthracite profits, so he decided to try to use anthracite directly to fuel blast furnaces, bypassing Darby's use of coke. America was running out of wood for charcoal furnaces, and fortunes would be made if the anthracite processes could be made to work. There seemed to be insurmountable problems. Anthracite needed a higher burning temperature than the coke the Darbys used. One possible approach was to pump hot air into the furnaces fueled by anthracite, the so-called hot blast process.
Something very hot happened here. The fire brick is vitrified. It feels like glass. This is all that's left of carbon furnace. In 1838, Josiah White's associates tried an experiment here. They used anthracite to smelt iron. The furnaces in America then used charcoal. The experiment not only involved anthracite, but also the hot blast. The other furnaces were using coal blast. Josiah White wanted this because he had an abundance of anthracite. He was looking for new markets, and he also had iron ore in the hills here. The experiment was not successful. After 1838, Josiah White decided to build another furnace downstream, but he knew he needed help, and he heard there was a man in Wales who could help. Josiah White sent for David Thomas.
Thomas was a practical man who had spent years in Wales experimenting with the hot blast process. He was attracted to Catasauqua, not far from the modern Bethlehem Steel Works, by equally practical means, the offer of money and a 5-year contract. Catasauqua stood next to White's Lehigh Canal, and on July 4th, 1840, Thomas was first successful with a run of iron. Others were quick to follow him. Anthracite furnaces sprang up all along the river. The Allenherne, the Southeastern, the Glendon, the Hawk End. The stones of the great Catasauqua works have crumbled, but Thomas's last personal venture, begun when he was nearly 70, still stands at nearby Albertus, the Lockridge Furnace. The anthracite process had succeeded. Within 30 years, when this furnace was still new, more than half the pig iron in the United States was made using anthracite, and most of it in this region. David Thomas had amply repaid America, but no triumph lasts forever.
David Thomas witnessed momentous changes during his lifetime. When he was a young man superintending iron works, his country, Great Britain, was the preeminent industrial nation. It led the world in the production of iron. He came to America. He presided over the growth of the iron industry in eastern Pennsylvania. He saw it in ascendancy. But then, in 1875, the center of the iron industry moved westward to Pittsburgh. The most remarkable event came shortly before his death in 1884. It was then that for the first time in history, American iron production surpassed that of Great Britain. The British were shocked. But only a century later, the Americans were shocked. For the Soviet Union and Japan surpassed America in the production of iron. Leadership, the glory of leadership, is ephemeral.
A bitter lesson which had been learned in Shropshire 100 years before.
We're back in England at the Quaker burial ground in Coalbrookdale. Abraham Darby I lies across the river in Broseley. Francis Darby, the last of the line to actively manage the firm, lies here in the Quaker burial ground. Abraham Darby I was an austere Quaker, a vigorous pioneer of the Industrial Revolution. Francis Darby did not live strictly according to the Quaker rule. He was a cultivated man, a collector of fine art. Abraham Darby won a patent for a cast iron pot. Francis Darby, he won a gold medal for his casting. The people, the company, and the county had changed. In 1789, when the French Revolution began, the county, Shropshire, was the leading producer of pig iron in the kingdom, and the company was the leading producer in the county. In 1815, after the Napoleonic Wars, Shropshire was a third-rate producer, and the company closed down its historic Coalbrookdale furnaces. The valley had become a plateau. The production was high, the quality of the iron was good, but the steep increases, the sharp breakthroughs in technology were occurring elsewhere. South Wales, and later, Eastern Pennsylvania. Why? Looking around this quiet Quaker burial ground, I can only suggest that families and companies molded and cast by determined men and women become strong and inflexible, like iron.
For a transcript, send $2 to this address. Major funding for NOVA is provided by this station and by other public television stations. Additional funding is provided by grants from TRW and the National Science Foundation.